Welcome back, friends. Again, in last lecture we derived flank radiation law. What did I say? In last lecture we derived flank radiation law using Planck's assumption, and we derived both in form of frequency as well as in form of wavelength. So today we are going to start or going to see what is Wien displacement law. The basic of Wien displacement law we already seen in very first lecture of this lecture series, where we talk about spectral distribution curve for black body radiation. So before starting anything, you know and you are aware that who am I, but still I want to introduce myself. So I am Amol Nande. So I am basically an assistant professor at Guru Nanak College of Science, Ballarpur. Of course, I am belongs to Department of Physics. So today we are going to see Wien displacement law, as I said. So this figure we have already seen in our first lecture, where we see that with increasing wavelength, the spectral distribution of energy is also increases. It first reaches to maximum energy and then again come back. And according to black body radiation, it emits all possible wavelength of radiations. But the interesting thing is, when you increase the temperature, the peak value, means highest velocity wavelength value, decreases. And for a given material or for any material, that maximum wavelength into temperature, means maximum wavelength into temperature, that product is always constant. So basically, let us define lambda m is the maximum wavelength observed at a given temperature T. Then lambda m into T is constant, that is equal to 2.898 into 10 to the power minus 3 millikelvin or 2.898 microkelvin or 2.898 microkelvin. Means the maximum velocity observed for a given temperature in black body radiation is always constant. The product of these two things are always constant, or in otherwise you can say that the maximum wavelength is inversely proportional to the temperature. If temperature is more, it is shifted towards lower wavelength. It's shifted towards lower wavelength. So that's what I said now. The wavelength of the highest observed for emitted radiation is inversely proportional to absolute temperature. Is inversely proportional to absolute temperature, and that is nothing but Wien's displacement law. That is nothing but Wien's displacement law. So if someone asks you, if you hit the black body radiation at 1000 Kelvin and at 7000 Kelvin, or you have two stars having temperature 5000 Kelvin and 7000 Kelvin, then where you get the maximum wavelength, for which the maximum wavelength value is greater. So your answer must be, it is greater for 5000, not 7000. It is greater for 5000 red hots, or just say that hot sun compared to the 7000 hot star. Alright, so in next this subsequent, now it is possible that we can derive Wien displacement law. We can derive Wien displacement law from Planck radiation formula. So what is Planck radiation formula? We have Planck radiation formula in radiation form, in wavelength form. E lambda is equal to 8 pi Sc by lambda to the power 5u into 1 upon e to the power Sc by lambda kt minus 1. So you know that mathematically, whenever there is a minimum value or maximum value, what did I say? Whenever there is a minimum value or maximum value, there is only one minimum value and one maximum value. That's why whenever you take the differentiation of that value, it is always 0. So similarly, we can say that when you differentiate this energy density or energy with respect to lambda, so for maximum wavelength lambda, it is equal to 0. So the above equations, E lambda is equal to 8 pi Sc by lambda to the power 5u 1 upon e to the power Sc by lambda kt is reduces to, agar aapne 8 pi Sc common nikala to you will get two terms in form of lambda. One is 1 by lambda to the power 5u and other one is 1 by e to the power Sc by lambda kt minus 1. So you have to use product formula of differentiation. You know that product formula of differentiation is d by dt of x and y is equal to first function derivative of seconds, means x, dy by dt plus second function derivative of first means y dx by dt. Similarly, here we do do the same thing. We first kept the second term, means this one is constant, and differentiate the first term, and then we keep the lambda to the power minus 5 as a constant, and we differentiate the second term. So when we bring this one 8 pi to right hand side is 0, so we left with minus 5 lambda to the power 6 e to the power sc by lambda kt minus 1 uska inverse plus minus 1 of lambda to the power minus 5, and the bracket terms raised to power minus 2 e to the power sc by lambda kt और माइनस sc बाय लैम्डा स्क्वायर बाय kt. ये देखो सेकंड टर्म को डिफरेंशिएशन करने के लिए आपको प्रोडक्ट रूल एज वेल एज चेन रूल लगाना पड़ेगा, क्योंकि इट इज अ फंक्शन ऑफ लैम्डा. पहले तो वो पूरा फंक्शन है, उसके बाद उस टर्म जो दैट इज आल्सो फंक्शन ऑफ लैम्डा. दैट्स व्हाई यू हैव टू यूज चेन फार्मूला. सो व्हेन यू ब्रिंग टेक दिस वन टू द राइट हैंड साइड एंड सॉल्व, so you left with minus 5 lambda to the power minus 6 upon e to the power minus sc by lambda kt minus 1 is equal to lambda to the power minus 5 divided by sc by lambda kt minus 1 whole square e to the power sc by lambda kt minus sc by lambda square kt. अपन ने क्या किया, सबसे पहले जो टर्म है उसको राइट हैंड साइड में लेके गए, एंड देन वी दिस वन द ब्रैकेट टर्म वी ब्रिंग डाउन टू डिनोमिनेटर. अभी देखो कॉमन क्या है, माइनस साइन कैंसिल हो गया. देन अगेन आपका लैम्डा टू द पावर माइनस लैम्डा टू द पावर 6 कैंसिल हो गया. यहाँ पे फिर से बचे 2 लैम्डा, दैट विल आल्सो रिमेन, उसमें से एक कैंसिल हो गया, एंड दिस टर्म होल टर्म कैंसिल विद द रेस्ट टू पावर 2, एंड वी लेफ्ट विथ व्हाट वी लेफ्ट विथ, फर्स्ट वी लेफ्ट विथ 5, यहाँ से सिर्फ 5 बचता है, sc बाय लैम्डा के टी टू द पावर sc बाय लैम्डा के टी डिवाइडेड बाय e टू द पावर sc बाय लैम्डा के टी माइनस 1. और when you take calculate for maximum wavelength, and you take this lambda and t to the left hand side and bring this 5 to the this side, so what you get, lambda t is equal to sc by 5 kt e to the power minus sc by lambda kt divided by e to the power sc minus lambda kt minus 1. alright, so अपने पास ये वाला टर्म था lambda t is equal to sc by 5k e to the power sc minus sc डिवाइडेड बाय लैम्डा kt डिवाइडेड बाय e टू द पावर sc बाय लैम्डा kt माइनस 1. इसको अपन ए नाम दिया, उसको रीअरेंज किया, एंड वी नो दैट दिस वन इज कांस्टेंट, दिस टर्म इज कांस्टेंट, एंड एवरीथिंग इट चेंजेस टू, वी पुट दिस वन एज sc बाय 4.96 is equal to b, and that is nothing but equal to what we can say 2.898 to the power 10 to the power minus 3 millikelvin. So therefore equation 1 changes to lambda t is nearly equal to 2.898 into 10 to the power minus 3 millikelvin. अपन ने क्या किया, go back, let's go back and check one more time. We just consider first right hand side term, और अपन ने we try to solve them. We try to solve them for the required conditions. So after solving all this term, we get left with this right hand side is nearly equal to 2.898 into 10 to the power minus 3 millikelvin, and which is a constant number. So we can say that lambda m by t is equal to constant. It is independent of temperature, it is independent on wavelength. क्योंकि इसका when you try to solve this one, you can ignore the higher order term. You can ignore the higher order terms. So lambda m is into t is equal to constant. This is nothing but exactly what we are talking about, Wiens displacement law. Maximum wavelength for a given temperature into temperature is always constant, that is nothing but Wiens displacement law. So thank you very much for your attention. If you have any question, where to find me, you have my mobile number, and those person who doesn't have my mobile number, they can contact me on my email.